All right, evening, folks. Well, my name is Tristan. I'm a solution architect here at Elasticsearch. Want to thank everyone for coming out to what I think is our first in-person meetup in I don't know how long. So I really appreciate everyone coming out. I hope everyone's enjoying the food. And then quick logistics check for those of you here in the room. Bathrooms, if you can imagine, we're in a square. We're in the bottom left-hand corner. You want to go to the top right-hand corner. So as soon as you exit these doors, just go diagonal. And if you get lost, well, there's only 4 corners. So anyways, thank you all for attending. There's plenty of food, so help yourself. There's some swag, just joint swag between us and Zebrium, some socks, water bottles, and all that. And if you really think you have too much, just remember you haven't been able to refresh it in about 2 years. So keep that in mind as you probably pile on more. But anyways, thank you all for coming. So I'm going to pass it over to Larry here, and we'll go ahead and get started. And if anyone has a question, we will probably figure out the mic situation. Yeah, Nico will figure that out. But anyways, in the meantime, just raise your hand and Larry will call on you. All right, great. Thank you, everyone.
Howdy. Hello. I just flew in from Texas this morning, so I'm saying howdy still. I just moved there 2 years ago. I've been in the Bay Area for the last 35 years. So I'm really happy to be back and I appreciate this warm welcome. In fact, this is a beautiful facility I've never been to before. So thank you all for that. So I'm not going to take up too much of your time and push the time limit today. I'm going to share a couple of things that I've learned, in the course of Zebrium's work that I think are really interesting and sort of hard-earned lessons that folks like yourself might appreciate. I figure you'll either leave saying, "Wow, that's amazing. I never would have thought that," or you'll say, "That was completely obvious. How could anyone not have known?" We'll see which one it is. So I'm calling this talk "Automating the Observer: Lessons from 100+ incidents." So when we created the talk title, it got created with 100, but it was supposed to be 1,000+, and so now I just put a plus there, so you get the idea. So I'm going to start by setting the stage for what it is that is motivating me in this talk. So here you see kind of a vanilla dashboard someone might set up with some basic network stuff and CPU. And if you'd scroll down, you'd see some memory usage stuff, just some basic metrics that anyone would know to collect on day one of any job. Nothing special. But I've been in this position a couple of times, and this position isn't so much about the metrics themselves. It's about noticing from my dashboard, which is, it's instrumented really well to tell me when there's a problem. But sometimes I don't know what the problem is, and it's not obvious to me. Now, we have other tools to help with that. We have alert rules that we set up, lots of monitoring, and so on and so forth. But this is kind of that situation where you're sitting there and you're like, you don't, and all of that, whatever the issue is fallen through all of that. You don't know what the problem is. It may be something completely new. And that's kind of the pain point that Zebrium is aimed at, which is trying to get to root cause quickly. And there's lots of ways you can do that. And I'm going to talk about one such way. So I'm going to start by just saying, and I may say it 100 times, everybody hates digging in logs. I have yet to meet someone in my career who just, that's what they look forward to. And in fact, I've found that when talking to people about, doing troubleshooting with logs, people will acknowledge, yeah, it's really important sometimes, but it's not all the time. It's a few hours a week or less where it really matters, where you're really under the gun to dig something out of a log. And I don't mean just like tailing a pod log. I mean like having to actually dig in and look. And when that happens, it seems very important and it's obvious that it's important. But all the rest of the time, you kind of want to pretend like it doesn't happen. It's kind of, you don't want to be thinking about it. You don't want to be optimizing for it. You don't want to be buying tools and hearing pitches about it. You just kind of want it to go away. At least that's been my experience. There's a company called Epsagon that recently got purchased by Cisco. And one of the founders said something that I found, I thought it was profound because I hadn't had the thought. And I just think it's a great thought. And the way he put it was, they're a tracing company, by the way, they were. And what he said was, for me, like the when is metrics, meaning detection, something's wrong. That's the best way to get that. The where is tracing, and oftentimes the why is logs, but they don't focus on logs or metrics. And I think that in a substantial number of cases, that's true. So I find that to be a useful insight. So in any case, I'm going to say that logs are often the best place to root cause a new issue. That's been my experience in life. And so when I started thinking about how to confront the root cause problem of an unknown issue, my mind immediately went to logs. So that gives you a little bit background for today's conversation. So if you look at the situation 20 years ago versus today, so I started my career in the Valley in 1997. If you look at things 20 years ago versus today, back then, all the software anyone cared about was shrink wrapped, except for a few websites. There were a few. They weren't that big compared to today's websites. You had sort of one incident at a time. And when you had that, it was shrink wrapped. There was one user somewhere complaining. You had one monolithic application with maybe 10 log files, maybe, usually one or two, sometimes 5, 10, depending on what it was you're talking about, as a rule of thumb. And so if you needed to root cause something, you would get on with the customer and you might just have them FTP the log and you'll just hunt and search your way through it. But today it's become a lot more difficult, right? So you've got hundreds of thousands of users and hundreds of services. And really what that turns into is, more than 1,000 log streams. So you need it gets hard to navigate your way through it. And that's a challenge that I think you need to confront when you're root causing a new issue. But what we still see today is most people will go to do root cause from logs by searching for things. And that's actually a perfectly valid way to do it. And in fact, what you'll find is people who have worked in a stack for a long period of time, they'll develop like an intuition about things that are harbingers, but also they'll know something that's rare when they see it. See, that's what I've come to realize is that the most important thing that experience can give a person is an understanding for troubleshooting, is an understanding of what is not supposed to be there, what is really weird or rare that they're seeing. And so we all know about what's bad in terms of errors and exceptions, and you can quantify that right out of the data most of the times, but what's rare, that's hard. And so that's leading into kind of the how we're going to go about figuring out how to do this, with machine help. So you notice I'm not saying the word machine learning. The talk title I never addressed today that was put on the meetup site, which don't call it machine learning, because I've learned when you call it that, people come in with a bunch of expectations. In particular, they're thinking you've applied some transformer model to your data and you're doing something. Guys, like if I'm learning from a stack from a customer, it's their application, how many petabytes or exabytes of incident data am I going to have to train with? Right? That's not how you're going to make traction, at least not right now. So in any case, I try not to say that. And I'm going to talk a little bit about the techniques that have proven fruitful. But that's just to give you that context. So logs are uniquely encoded for human troubleshooting, right? They're typically human readable statements about what happened. And for all practical purposes, they have unlimited dimensionality, meaning A developer can make them as long as he wants. He can embed all kinds of variables. He can have as many, unique printfs into some log file as he wants, or, it calls into a log service with a given template. He can do as much as he wants. There's almost no limit. And there doesn't have to be any coordination with downstream tooling. There doesn't have to be. So this makes it actually really valuable, because a lot of times you'll see people who do structured logging, they'll bother to structure and catalog a certain set of events, but then there's a debug set, like it's 10 times as much, and it's in a log somewhere, right? So that's the kind of information that we really want to get into. So let's take a look, if we want to automate this process, let's take a look at how humans go about finding the root cause indicators in a log file. So first of all, when we're talking about doing root cause from log file, I don't mean sort of in a broader sense of root cause where you might say, well, this could have been avoided if we had had a process whereby we reviewed, our code more rigorously or whatever. I'm not talking about that kind of root cause. I'm talking about events in the log file, which will get the troubleshooter far enough that they'll be able to remediate the issue at hand. So that's what I mean when I see root cause. And you won't always find root cause indicators in logs. So I'm going to talk about when there is some information there that would give you root cause indication. So the first step is detecting a problem. I mentioned this already. Metrics are great for that. Everybody has alert rules set up on metrics, like my endpoint latency is too long, or I've been over, 95% CPU saturation for 5 minutes. Whatever it is, people have those, okay? And metrics is probably the easiest way to get started with that. But there's other ways to detect problems. Some of those come from logs. Some of those come from tracing. Some of those come from human processes, like someone opens a ticket, they complain on the phone, whatever it is. So that's step one. And I'm actually not going to talk too much about that today. When we look at the problems that exist today, it's not the detection. People have great ways to do detection. I'm more interested in getting to the root cause once we know there's a problem. The next step is they're going to notice rare events. I mentioned this earlier, but there's going to be someone, everybody knows a person, they're in a closet. Everyone knows who they are. Well, take Joan the log file, she'll know the problem. Go, every day someone throws a stake into Joan and closes the door because she's cranky, but she reads through log files. She's been there, working there for 15 years. That's the kind of person I'm talking about. They're going to know by looking at a log file. They're going to say, this is weird. I've never seen that. Every time I see that, it's a problem, which means it doesn't happen very often, and so on, right? So they're going to find these rare events. The next thing that a person might do is notice that a problem, like a set of errors, or the indication that they got in the first place, the detection on an alert rule, and the rare events that they're finding are abnormally close in time. And abnormally close in time doesn't mean I can just say it's within 5 minutes. It depends on the stack and the application. Sometimes, like in a high throughput, storage application, milliseconds are an eternity. And in other applications, like a Slack client, that's not true. Maybe minutes is a more appropriate kind of time window. So really, that's entirely data dependent, what close in time means. But nevertheless, you get the point, right? You see something blows up, and then you look around, you see something weird, right? Everybody's probably saying like, this is all obvious. Okay. The next thing that you'll do is you'll take those rare events and those bad events, and you'll construct a narrative in your mind that makes sense as to what happened here. And that gives you kind of your root cause that you were looking for, that you're going to use to the extent necessary to remediate the issue. So now I'm going to show a quick example, and this is the simplest example from real data that I could find. So here we have an on-prem Atlassian stack running on a single server being used by a small development team. And in the Jira log, we have this fatal, exception that gets thrown and logged there. And it got thrown and logged here because someone going through Jira through the web interface was trying to access some element in Jira, and they got an error because of this error right here. So that this reflects what was happening at the time the error was thrown to the client. So that's great. And we kind of have the sense that, okay, the database was having a problem. We can tell that from this message. It's actually kind of diagnostic in and of itself. That's great. But why? Why was the database having a problem, right? So if we then look in the same stack, but we go to the syslog on the host, and we go back 191 lines from that timestamp, we find this, which is somebody actually logged it and stopped it, because as it turns out, he was getting ready to do some administrative operation, didn't tell anybody. So this is the kind of thing that if you have a system that's built to understand what's bad and what's rare, and do a temporal correlation among them and find things that are those kinds of anomalies that are unusually close in time relative to what you usually see for anomalies on that stack, you can get reports that look like this, right? It's not that complicated. I think where it gets a little more complicated is, okay, great, but how much recall does that give you? If you just use that simple approach, what percentage of the time can you actually end up finding a useful root cause? There may be other things you'd have to do, other analyses you'd have to perform, right? This couldn't cover everything. So I'm going to talk now about the results from a third-party study that took 2 months. It was conducted by Cisco Systems. If you're interested, you can go to our website. There's a case study somewhere linked in there. You can go read it. But let me just give you the Reader's Digest version. So basically they were looking at Zebrium. Oh, someone's been waiting and I have not admitted them. I feel like a horrible host. You got them? Thanks. All right. So, right. So they were considering buying Zebrium. And the reason is they've bought so many companies with so many different pieces of technology for so many decades that their support burden of trying to kind of maintain those systems for customers is onerous, right? And so anything that can make it faster to find root cause from logs is obviously worth tens of millions of dollars to them. And so that's why they were looking at Zebrium. But they didn't really believe what we were telling them because, well, they've tried a number of different approaches themselves and haven't had as much success. And so they wanted to prove it. So what they did was, or disprove it. So what they did was they picked 4 products that to them are very different. There's like a monitoring application, the WebEx client. What's the other one? Their UCS server. It's like a brick of servers. And there's another one. Anyway, it's all in the study. So they picked 4 different product lines and they said, okay, they sent their escalation engineers off that said, go find from the last year or so, go find the cases where you feel like we have the best sort of documented data about the case ended up being solved by something in the logs, and we can point to what in the logs were the root cause. Like that's all documented in the case notes very well. So they went off and they found 200 cases. And then they ran all those through the software. And what they wanted to see was, what is our recall? Meaning, for those 200 odd cases, how often did we put the right events that were required to find root cause into this little report that we generate? Right. So they found out that that accuracy was about 95%, a little more than 95%, which was great. You can't necessarily generalize that to everything in the world. Different stacks are different. I would say it's probably not exaggerating to say the rules I've walked you through today, just that general approach of finding bad, finding rare, and correlating, that is enough to give you probably better than 90% in any stack that we've worked with. And that's really something. Like, it didn't have to be that way. It could have been 20%. It could have been 5%. It could have, right? So that's something I wanted to share with you, which I consider to be like something that's learned. It's like a diamond that we've dug up, and I like to share that because there's lots of other stuff that we've tried and we've spent time on and we'd be happy to do if it was always necessary. As an example, let me give you an example where that approach doesn't work. Let's take a look at that 5%. Sometimes you're not collecting metrics somewhere. It's some application, you've got a log bundle, you don't have metrics. But if you look in the logs, there will be something that gets submitted every so often with numbers in it, okay? And in that case, that event type keeps happening over and over again, and it's emitting numbers. It's saying, this minute, the count of widgets is 5. This minute, the count of widgets is 6. And then all of a sudden it says, oh my God, there's 600 widgets this minute. And so you need to not just look for that event type, that event per se, but you need to know that that value in that parameter is anomalous, okay, out of bounds of what's typical. That's an example that does not fall into the rule that I have been explaining tonight. And that is required many times. And it may very well be that if there weren't other places that people look for statistics, that may be required more often than we saw in this study. But people, like I said, people are already working with metrics. It's very easily worked with. It's pre-structured. It's a lot easier to work with than logs. So maybe that explains it. So now I'm just going to take you back to that thing that I showed at the beginning where we said, now what, right? We saw our dashboard and there was, there was this stuff up here with these dips, right? It was some generic dashboard that we had. And we said, now what? So now what I've done is I've overlaid. So this is really what kind of gave us the impetus to reach out to speak with Elastic folks, because we just recently published an integration with Elastic where it's pretty easy to hook up our dashboard into your Kibana. And so you can put the little Zebrium widget here. You see this little red line here? That means we generated a report at that time. And then over here, there's a link to it, basically. So that's kind of been our answer to it. And I'm actually really excited to have a presence in Kibana and on the Elastic stack, because I think right now, in terms of momentum, Elastic is one of the best things going. So I'm not sure how we are doing on time. I did want to take a moment and give you some examples from a real world, a little more complex incident that shows the rare and the bad and all that, but I'm not sure where we're at with time. Does anyone know? Okay. All right. So, so let's say I clicked on that link down there. I'd end up in this nightclub looking thing here. Okay, which is our UI, which I love. In fact, I'm a big dark mode guy. Some people hate that. Okay, I understand. But anyway, so ignore the nightclub aesthetic for a moment. So that little report that I showed you here, all we did was we ran a litmus chaos test in this case. So anyone here familiar with litmus? Have used it, or at least familiar with its use in like Kubernetes microservice apps? Okay, so essentially it's one of these called chaos tools or chaos engineering tools. The idea is it makes it really easy to take some application, whatever it is, especially if it's deployed with Kubernetes with a chart. It's really easy to then take litmus and just start breaking things in there, okay? Disrupting services and communication among services, disrupting things at different levels of the host, depending on how much chaos you want to reach and wreak. And then there's all kinds of, different named tests that people have created. There's like a database of them, you can go pick. So what I'm showing here is it's called these dips here that we saw in that dashboard that you're seeing up here. It was caused by the pod network corruption test. Now, you may notice that when you land in this report, the first thing you see here over here is pod network corruption. It's interesting because, let me scroll down and show you. Whoa. Didn't want to show you that way. Where'd you go? Right. So purely from a So purely from a what happened on the host perspective, like what broke, this is probably the closest thing that you might say constitutes a root cause. It's kind of telling you the fallout from what the chaos tool did. It just misconfigured an interface. And that shows up in the syslog. But what I love about this example is because we can do a little bit better, right? We can actually go back and say, actually, if we go back a little bit further in time, there's a bunch of rare stuff that happened here too, including somebody spun up a pod network corruption test. So I guess that is kind of the root cause too. It depends on how you want to look at it, right? But you can understand, I guess, a bit about how this got put together. So let me explain. So as these events were coming in, you see there's some rare events up here. And then these guys with the little blue finger, what we've found is that if you take the first rare thing and you also look in that log stream immediately after that, you'll often find some similarly diagnostic stuff. So that's kind of why those are there with the little finger. But then it gets a little bit more interesting. Now, so we've scrolled down, we've gone about half a minute, get down to here. Okay, so this is, I don't know, 20, 30 seconds-ish, I don't know, this whole period of time. So down to this point. What we saw here was the chaos experiment was begun. So there's a deployment of containers and such. There's some damage done to the interface configuration. All of that gets captured. A cluster gets made, a temporal cluster of rare stuff, but that's not enough to make a report because there's nothing bad. I mean, not bad enough. And you get to kind of tune this if you want, but in general, people don't. What then happens is this. As soon as something breaks because of that, then we'll say, okay, let's create a report out of that and let's put it into the dashboard. So you could click down. And these are kind of TF-IDF terms, but they also factor in the rareness of the event type, not just the word. But that's the concept. So you're trying to pull out the rarest tokens here among the typical logs. And then what happens is more stuff, happens that's rare, and we'll if it's within that time interval that's still, closer in time than usual for those anomalies on those streams, we'll put it in here. So now you get your report. And that's kind of how that works. So it's, in general, what we've found is you can get great results doing this one simple thing. Now, what I should say is it's not entirely a simple task because the most important thing to do what I've shown is to be able to say, when's the last time you saw something on a given log stream? Like, how rare is an event type? To do that, you need a catalog of events, but we're talking about largely unstructured events. Now, there are techniques that have been out in the market for 10 years to structure events. Probably the first was the Log Insight that got bought by VMware like 10 years ago. I'm quite certain Elastic has an LCS based and perhaps other approaches sort of tool pack that does some of that structuring. And does it really well. And so what's needed beyond that? So what we found was that specifically for diagnostic troubleshooting, if you're doing LCS, what you'll end up with is stuff you see often will get structured well, and you'll have an other bucket, kind of. And that other bucket, it shrinks as you see more examples. But the problem is always that the first 1 or 2 times you see something, is going to be the most important time to know that it's a new event type, that it's not any of these other things, to be able to put it in its own bucket. And that requires a little extra work. And so we, we spent quite a bit of time of our sort of engineering capital solving that problem up front. That's really all the work that I did for 2 years before I went and sought funding for this company, was solve that problem. Like, know when something is rare, even if I've only seen it once or twice. So if you can do that, and I'm sure there are other people who can do it much smarter than I am. There may be other, projects underway right now that are trying to do that. I think that plus, the bulk of what I've shown you today kind of gives us a foothold into root causing from logs automatically. And I didn't have to say anything about neural networks. I didn't say anything about it, right? And so that's why I've learned not to say machine learning. It's hilarious. So I went on Reddit, okay, SRE or something, one of these. It's like, yeah, so we'd love to get some feedback from some people. So we have this machine learning approach. Like the flames open up, like the flamethrower opens up. That's all garbage. Machine learning doesn't work. Everyone who says that is lying. Here's this PowerPoint from an SRE at Google 8 years ago, and he says that, so I've given up. I don't say it anymore. So that's it. That's all I had. Thanks, guys. Really appreciate it. I'm happy to take questions. I like the way you think. I'll need to check on that and get back to you. Please. But see, right. So, but the last time we raised money would have been sometime before we've reached all of this fruit of our labors. So I'm sure that valuation would not be the current value. That's why I'm saying, just reach out to us. We'll talk with you.